Hello, we're doing checkpoint 4.34. We want to use a second derivative test to find the local extreme values for this particular function. Okay, our first step is going to be critical points. We need to find some critical points and run that through the test. To find critical points, we'll set our first our derivative with respect to x equal to 0. That's going to be 3x squared plus 2y minus 6. We'll set that equal to 0, and we will also set our derivative with respect to y equal to 0. And that would be 0. This is a 2x. And with respect to y, this is going to be minus 8y. Okay. Now, if we set them equal to 0, I think solving for this and putting it into solving for the derivative with respect to y equal to 0 and putting that into the other equation would be useful. So I'll say 2x minus 8y equal to 0. I think if you solve for x, you're going to get a positive 4y. We'll use that and put it into this equation. We will get 3, and then we'll put 4y quantity squared plus 2y minus 6 equal to 0. And then this expands to 16 times 3 is 48. Y squared plus 2y minus 6 equal to 0. And I think we can take out a 2. That might make things a little bit easier. 24y squared plus y minus 3 is equal to 0. I think this is factorable. Let's see. 24, several possibilities. I think 3 and 8 would do. 3y, 8y, and 3 times 1. So 3 times 3 is 9. 9 minus 8, I think, is our winner here. And if we set this equal to 0, we're going to get y equals to positive 1/3, and y is equal to negative 3/8. Okay. Now we will need to put that back into the equation to get our x values. If we put y in for if we put the y value here, we're going to get x is equal to 4/3. So our first point is going to be 4/3 in for x and 1/3 for y. And then if we put 3/8 here, negative, it'll be negative also. The 4 and the 8 would cancel. That's 3/2. So x would be negative 3/2, negative 3/8. Okay. Those are our 2 points that we will need. Okay, now we are going to need our second derivative for the analysis. Let's see if we can squeeze that in here. We need to take the derivative. So the discriminant, we'll call it. We need to take the derivative with respect to derivative of fx with respect to x. We'll call that fxx. And that will be just 6x fyy. The derivative of this with respect to y, that's just negative 8. And then fxy, which is equal to fyx, is either the derivative of this, the fy with respect to x, which is 2, or the derivative of fx with respect to y, which is 2. Okay, so now we have our information for our discriminant. Then we can write our discriminant d is actually equal to d is equal to fxx times fxy, which is negative 48x minus 2 squared. So that's negative 48x minus 4. That's our discriminant, and that's what we're going to use to test our function, or to test our points. Okay, let's take our first point and put that into our d function. So d evaluated at 4/3, 1/3 is going to be negative 48 times 4/3 minus 4. 3 into here is 16. 16 times 4, 64. Well, in any case, this is negative 64 minus 4. Well, negative 68, but the whole point is that this is equal to 0 or less than 0. This is a negative number, and so we can conclude that this is a saddle point. Saddle point. Okay, and then we find our negative 3/2, negative 3/8 point. Put that into our discriminant, negative 48 times negative 3/2 minus 4. This will give us a positive 24 times 3 is 24 times 3 is 60, 72, positive 72 minus 4. Well, in any case, that's bigger than 0. So when our discriminant is bigger than 0, we have to do one more test, and that is to put that point into fxx. So that's minus 3/2 minus 3/8. There's no y's here, but we still should put these values in. So that's 6x, and that's going to be a negative value. So a positive and a negative here. Negative means it's concave down, so this must be a maximum point. Max point. Okay, so we have a saddle point for the 4/3, 1/3, and a maximum point, a local maximum at negative 3/2, negative 3/8. All right, I hope that helps.